Ignition sequence starts. 5, 4, 3, 2, 1.
Lately, I've had you flying more with rockets than anything else, and we're just getting started. Welcome back to the channel, where space isn't just a passion, it's a destination.
You know, there are elections that come and go. Some elections are, important, some are not. But this one.
Today, we're diving into another journey through stars, rockets, and dreams ready for liftoff. Are you ready for this new beginning? Buckle up, we're taking off. Nowadays, flying on a rocket is starting to feel like hopping on a plane, at least if you're a millionaire. Just look at celebrities like Katy Perry and many others. Space has become the latest status symbol. With Elon Musk on one side and Jeff Bezos on the other, space travel is quickly becoming part of everyday conversation. But have you ever wondered how a rocket actually works? And more importantly, just how complex is it to make one launch into space? But in reality, behind the dream of spaceflight lies a fragmented, highly complex world that's anything but simple. It's a universe built on extremely precise mathematical calculations, advanced engineering, intricate connections between hundreds of systems, ultra-resistant materials, and cutting-edge technologies. Launching a rocket into space isn't just difficult, it's one of the most demanding challenges humanity has ever faced. Even the tiniest error can lead to catastrophic failure. Today, there are many types of rockets, each designed for specific purposes: orbital, suborbital, reusable, heavy lift, satellite carriers, and crewed vehicles. Every mission is a perfect symphony of physics, chemistry, electronics, and software. But it all begins with a surprisingly simple idea, at least on paper. Newton's third law of motion, also known as the principle of action and reaction. What does it tell us? That for every action, there is an equal and opposite reaction. And that's exactly how a rocket works. Exhaust gases are expelled downward, and the rocket is propelled upward as a result. Sounds simple, right? In theory, yes. But making it work in practice requires a deep understanding of physical laws, fluid dynamics, extreme temperatures, and how to control a vehicle traveling thousands of kilometers per hour in space. But in simple, everyday words, what actually happens when a rocket takes off? Well, think of it like this. The rocket has a propulsion system that burns a mix of fuel and oxidizer. This combustion creates very hot gases, which are expelled at incredibly high speeds downward. And according to Newton's law of action and reaction, those gases push the rocket upward. Rocket thrust is caused by the rapid expansion of gases created when the propellants burn. These gases are trying to escape as fast as possible, and they shoot out of the engine at high speed. The result? The rocket moves in the opposite direction. So far, it sounds pretty straightforward. But behind this simple idea is a world of extreme precision, advanced materials, and incredibly complex control systems. Now, let's dig a little deeper and really understand what gives rockets the power to fight gravity. To really understand how rockets work, we also need to know the difference between solid and liquid propellants. A solid fuel rocket is one of the simplest and most reliable types. In this kind of engine, the fuel and oxidizer are already mixed together into a solid substance. This material is compact and dense, with a consistency similar to hard rubber or thick gel, and is shaped into a cylindrical form with a central core that helps it burn more efficiently. These rockets are also known as boosters, and you'll often see them attached to the sides of the main rocket, like in NASA's Space Shuttle or the Ariane 5 launcher. Their job is to provide a powerful initial thrust during liftoff, helping the rocket overcome Earth's gravity in the first crucial minutes of flight. One of the key features of solid rockets is that once ignited, they cannot be turned off. The combustion continues on its own until every last gram of propellant is burned. This makes them extremely powerful, but also less flexible when it comes to control or mid-flight adjustments. Solid fuel rockets are widely used because of their simplicity, durability, and strong liftoff power, even though they're not ideal for fine-tuned space maneuvers. In the next section, we'll explore liquid fuel rockets, which are far more complex, but also much more versatile. While solid fuel rockets are simple and straightforward, liquid fuel rockets are much more advanced and also far more complex to operate. This kind of engine requires many more components to function properly. Everything must be precisely engineered and work in perfect coordination. A liquid fuel rocket engine includes two separate tanks, one for fuel, like liquid hydrogen or kerosene, and one for the oxidizer, such as liquid oxygen. High-pressure pumps that push the liquids toward the engine. A turbine to power the pumps. A combustion chamber, where the fuel and oxidizer mix and burn, producing hot gases. A nozzle, which directs and accelerates the gases to create thrust. All these components must operate in perfect sync, and each one is a major engineering challenge. Even a small failure in one system can cause the entire mission to fail. But there's a huge advantage. Liquid fuel rockets can be throttled, controlled, and in some cases, even shut down, and restarted mid-flight. This makes them ideal for precision maneuvers in space, like orbital insertions, trajectory adjustments, and controlled landings. But what are rockets really used for by humans? Rockets serve many different purposes, including military applications, launching satellites into orbit, sending probes into space, and for general space exploration. Thanks to their ability to reach Earth's orbit and beyond, rockets are essential tools for better understanding the universe, as well as for practical applications like communications, climate monitoring, and Earth observation. Certainly, the space race and the competition among today's billionaires have accelerated the development of new technologies at an incredibly fast pace. Think about it. We managed to send humans to the moon back in the 1960s. But the question is, did it really happen that way? There are theories and mysteries that still raise questions about what actually happened. And today, with the advanced technology at our disposal, who knows what the future holds? Every new step in space research is a challenge, and each rocket launched is a piece of history that brings us closer to understanding the cosmos. As rockets continue to explore the boundaries of the universe, the future of space missions seems to be truly limitless. For now, I'll stop here, but the journey to explore space is long and fascinating. See you in the next episode.